Are AI tools helping development or hurting development? This is a question that keeps being asked ever since we had AI tools. And there are various arguments for and against. And I've been talking about this for a while, where things could go wrong. But now we have a new piece of evidence that I'd like to examine. I got this through Ken Beck's post talking about this report published by Faros. And let me read you what he says. I've been coding with a genie for a while. Here's what I see. I ask for something, it hands me code. I take it an hour later, I'm deleting it because what I accepted wasn't what I needed. There is a story going around that this part is solved. Machines write the code now. People just review it. It arrives as a confident headline with the caveats in small print. Faros, a leading engineering operations platform, recently put out a new study on AI's real impact on output, and I've partnered with them to dig into it. And this is what I'd like to do as well. Look into the proof of this AI engineering report 2026 by Faros called The Acceleration Whiplash. Welcome back to Think Design Work Smart. I'm Alex Bulbaka and I'm coming at you from the Mosaic Work Studios, and today we are examining this question. Is AI helping, hurting, somewhere in between? What is true, what is not true about using AI tools for software development? Let's look at the report. The report has about 30 pages, so I'm not going to go through all of it. I'm going to skim through it, and the link, as always, is in the description. You can download it for yourself. But let's start with the executive summary, because this tells us a lot of interesting things. More code, not production-ready code. When AI coding tools arrived, the promise was clear. Developers would work faster with an intelligent assistant at their side. The human was in charge, the AI suggested, and the human decided. That is not what happened. As model capabilities improved and vendor ambitions grew, the framing shifted. Copilots became peers, and without a deliberate decision by most organizations, AI crossed the threshold. With 60% of AI-generated code now being accepted in the code bases, the distinction between assistant and author has collapsed in practice. Not an assistant, the author. And this is something that I've seen indeed. The current thinking about using AI in your organization is to treat AI assistants like a digital colleague. And that's kind of where we are. This report measures what that transition has produced, drawing on 2 years of data from 22,000 developers and 4,000 teams across the Faros platform. The throughput numbers are undeniable. Task completion is up 34%. So we are finishing more. Epics completed per developer up 66%. Again, finishing more. Tasks involving code specifically have increased to 110%. AI is writing more code than ever. But what it is not doing is writing production-ready code. Bugs per developer up 54%. Incidents to PR ratio more than tripled. Median review time increased 5x. 31% more PRs are merging without any review. The relationship between AI adoption and production quality is worsening, not stabilizing as adoption deepens. We call this the acceleration whiplash. AI has flooded a system built around human-paced development and human quality code with output it was never designed to absorb. The acceleration is real, but it is deceptive. It masks the strain building at every stage downstream. Adding reviewers, expanding QA, or investing in faster incident response treats the symptom. The problem must be addressed at the source during code generation. And we have some graphs. I'm going to go through some of the graphs. Now, there's something about the research methodology. Honestly, I'm not trained in this stuff. So I hope other people will peer review the statistics and see whether it matches or not. Generally speaking, I'm a bit wary of these and a bit skeptical of all these reports because it's very difficult, if not impossible, to get relevant data from software development. Right? Is the number of pull requests a good number? Well, there could be small, they could be larger. Is the number of epics a good number? Well, I don't know. Didn't the adoption of AI tools change the way you think about epics, and that influence the number of epics because they are sized differently? So the problem with all this is that everything is relative, and the problem is more systemic than just, these are some numbers and we can look through them. However, I find the results quite plausible, and the reason is that they match the expectation of anyone who knows about complex adaptive systems and queuing theory. So if you have queuing theory, the idea is that if you have stages, so code, we generate the code now, okay, before we were writing the code, and then we, test, put in production, put in staging, put in production, and so on, and we have the delivery pipeline, basically. And now, if we speed up one part of the process, whichever it is, the overall speed of the system is still, throughput. The overall throughput of the system is still based on the weakest link. And that is, therefore, it's not very surprising that if you increase the speed in generating code, you don't necessarily end up with better results at the end. Instead, what you end up with is either defects or bottlenecks, slowdowns over the other steps. This is something that we expected. Anybody who knows about queuing theory expected this. Everybody who knows about complex adaptive system expected that the system will start to adjust around these things, and that we'll have a weird things happening for a while. And that's where we are right now. We are still in the process of figuring out how to integrate these tools into our processes. And they have some idea of how to do that. Spoiler alert, I think they are wrong and we need to do something completely different. But I won't jump there. Watch until the end to see why. Okay, so I'm gonna skip research methodology. Basically, what it's saying, more code, declining quality, accelerating incidents. And now let's look at a few graphs, because these are the most interesting. First, AI is now the standard, not the experiment. 60% of developers use at least one AI tool weekly, up from 40%. Well, this was to be expected. I think most people use these tools either for curiosity or for something in the workplace. I'm not sure that it's so relevant. 80% of teams exceeded the 50% weekly active user threshold, up for 50%. So in the majority of the teams, you have at least half of people using AI every week. If you have a team of 6 people, 3 are using every week in 8 out of 10 teams. 25% of PRs are reviewed by an AI agent, up from 0%. Right. And this is a signal to me that we move the bottleneck from writing code to review, and we dealt with that bottleneck by introducing more AI. Is this the best idea? Well, AI is one of the tools we can use for review, but I think in order to get an appropriate review, we need to use 3 mechanisms: AI, tools, static analysis tools, and so on, and human. You cannot do without any of these right now. Okay, so this is the first graph. The second graph, even more interesting. 60% 7.4%. So 2/3 more daily PR contexts per developer. Separate pull requests touched in a single day. So if until now you are touching, I don't know, 10 pull requests, now you're probably going up to 16 pull requests per day. That's a big increase. Especially since I know that pull requests tend to be very large. That's not great. Plus, it's almost 20%, it's 17.7% daily task context per developer. So if you were working on 10 tasks until now, you're probably working somewhere around 12 tasks per day, which is not great. And then we have plus 14%, let's say, work restarts per developer, tasks returning to in progress after moving to another stage. So that basically means that you started, you generated some code, you thought that you were done or got to a certain level, and then you need to go back, or another developer needs to go back. That's a very bad, that's a sign that your process, as I was describing in the queuing theory, it's generating too many errors. And in order to do that, we know from queuing theory what we need to do. We need to do the thing that so if we have process A, process B, you do process A, then you do process B, and then you get the errors, get bugs, then you need to do a little bit of process B before process A. So yeah, theory of constraints, queuing theory, and complex adaptive systems. These are the things that we know we should look at. Task returning to in progress after moving to another stage, and 25% in progress tasks stalled 7+ days. Started but no PR or activity in the past week. Okay, so we have higher context switching. We have increased cognitive load, which means that, and then we have work that's stalled. The picture is a development environment where it is easy to begin and hard to finish. Easy to begin, hard to finish, which is exactly the opposite of what we're trying to do with Agile and Kanban. The main idea in Kanban was stop starting, start finishing, and now we are back to start starting and stop finishing, which is not great. Okay, let's look at the output. Epics plus 66%, great. But the question is, what is epics now? Task plus 33%, pull request plus 16%, but deployment less by 11%, which means that we are not getting to the point where the code is actually done and can go to deployment. And to add to that, we have code churn plus 861%. So 8 times more code deleted per quarter for merged code. To me, this is the biggest one. That's the biggest thing. We are creating a lot of code, but then we have to delete a lot of it. Much more than we have to delete before. So that's relevant. No matter how you structure your code and so on, you cannot lie about this one. This parameter is actually very solid. Now let's talk about complexity. For high adoption, you get plus 60% files edited per PR, per pull request. So a lot more files edited in the same time. Increased pull request size by 50%. Okay, so it's interesting. Not only the number of pull requests increased, but also their size, which is, oh boy. So this puts a lot of cognitive pressure. People either don't review that and give up, or just don't review it sufficiently, or just are rejecting those. And that's what's happening. Developer foot per month, plus 150% files touched per developer. Yeah, I've seen that. So that's not a surprise. Even with my way of working, I still get Cloud Code to edit a lot more files than I used to. And then plus 11.7% repositories touched per developer. Okay, this is a function of how the code is structured. And then let's talk about code quality before merge. We get 25% more review comments per PR, plus 31% PR skip review entirely. So 1/3 of the pull requests are not, well, an extra 1/3 are not reviewed at all. That is bad. And what they are saying is the 31.3% increase in PRs merged without any review is the most urgent finding in this section. Code is entering production without oversight at a meaningfully higher rate as AI adoption has scaled. This is scary. This is scary because we need to compensate somehow. Okay, maybe you don't have a human for everything, but geez, what happens with security? What happens with performance? What happens with there are things where you can review with AI. Don't get me wrong. Although I'm starting to wonder whether it will be economically feasible to do so. But you can do reviews with AI. You can do reviews with tools, but they only take you so far right now. You can still miss, particularly when you increase the number of pull requests and the code size, you increase also the number of bugs that can escape and the number of security issues that can escape. That is scary. Flow and efficiency. Okay, this is very interesting. The workflow is slowing down at every stage. More work entered the queue, the humans managing it could not keep up, as expected. So, in progress, plus 225. Jeez, this is huge. So actually tasks stay for longer in progress, at least twice in the quarter, times longer in progress. In ready for review, they stay 1.5 times more. In review, they have 2 times more. And in QA, okay, 1/3 more. Well, of course, we sacrifice QA. I mean, as usual, this is the usual way. And the lead time has increased by 480%. Jeez. Now this is really bad. This is really bad. And this to me shows that the only way to deal with this is actually to restructure your workflow. And this has to be a transformation. It is no longer sustainable like that. It will start to blow up in various parts of the pipeline. Okay. So there are more here, but let's see production quality. Almost 2.5 more times incidents per pull request. So outage, security event, or customer-facing failure. Plus 58% monthly incidents, plus 54% bugs per developer, plus 28.7% bugs per pull request. So we are creating more buggy code. Yikes. This is not great. Okay, so now let's go to the conclusions and their recommendations. And what they say is the data in this report is diagnostic. Below are 10 recommendations to translate it into action. Not every metric applies to every organization at the same level of urgency. All right. And let's see what they are saying. Measure your incident to PR ratio on your monthly code change volume against monthly incidents. Okay, let's say you measure this, but what do you need to do? Define a review policy, then enforce it as a gate. And of course, this is the first reflex that you have with theory of constraints. Whenever you see a problem, you see bugs, what you are saying is what we need is to add another gate. This will only slow down, it's fine in this case. You need to slow down, but this is just an incremental and particular and short short-term solution. I think we can do a different one. 3, set PR, pull request size guidelines for your coding agents and enforce them. Okay, that makes sense. Smaller pull requests, easier to review, but it will increase the context change for senior developers, which is not that great. You have a limit there. Build quality gates into the development environment, not the review queue. Oh, okay. Now we are getting to where closer. The goal is test-driven development at the agent level. Yes, obviously. This is what we've been telling people for years. Use test-driven development, early feedback. This is what we need to do with agents. Use workflow stage times as input to a continuous retrospective process. Yeah. Watch work restarts as a signal about agent context quality. Yeah, you need to manage context. You need to manage the token economy. You may need to add in some rag over your code bases, a knowledge base that's properly done, a lot of things like that. Distinguish between human and agent review comments and act on both differently. Build an automated investigation loop around code churn. Maybe. Repurpose engineering capacity. Do not reduce it. Yeah, that's definitely a good recommendation. And build a context engine for engineering environment. Yeah, another one. So here's what I would suggest is a better solution. I think they got about 3.5 correct conclusions from this. Here's what I think needs to happen. What needs to happen is that we have smaller teams of 2, maybe 3 people who are working with one AI assistant on one problem at a time from the very beginning to the very end, which means to production. And they work on everything with the help of AI agents and AI assistants. And the way they do that is like a pilot-copilot kind of thing in an airplane. You need to pilot the airplane, but if the pilot needs to take a break, then the copilot takes over, and so on. And so what you need is to have these small groups of people that work over an agentic system that has the feedback loops built in for test-driven development, for test quality, and a lot of other things. And they do this, and they take one task from beginning to end. And then the skill becomes, we have this big problem, split it into smaller problems, take it all the way to production, and be responsible of it. I don't see any other way we can make this work. I think this is the only way. Because then you have, there's no more queues because you're doing everything in one constrained and bounded context. And people can manage this cognitive overload. And by being able to switch between them, they can manage it over time and avoid getting burnout and getting overwhelmed and leaving things pass and so on. And in order to do that, you need an infrastructure. And the infrastructure is the context engine, as they are calling it. So you basically need correct level of documentation, a RAG over your documentation and over your code, maybe even, so that, and connect it to your coding assistant so that you can get very quickly the information that you need, get only the context that you need, do not overwhelm the assistant's context, and have the built-in checks that allow it to get to the point where you can review the code and be fine with it. But this thing where we just generate code on top of code, and we end up in pull review sessions where we don't know what we are reviewing, and we are reviewing 10 things at once and so on. It just won't work. It won't work anymore. So I think we need a more drastic change. So as I was saying, AI will either be a very disruptive force, or it will just be a bubble and burst. We don't know where we are right now. But if the bubble doesn't burst, when the transition will need to be slower, then we'll need to do a faster transition. That's kind of where we are. I still don't see a way for AI to not be used in software development, since you can have now local models and a lot of other things. So even if OpenAI and Anthropic go away tomorrow, we will get the models. We'll run them locally on corporate infrastructure. We will be able to do that eventually. Maybe not next year, maybe in 2 years, maybe in 3 years, but eventually you'll get there. So the only thing that happens if these companies fail in some way is that the change curve will be smooth. But if they stay, then we'll need to change faster. And that's what I have to say about it. What do you think about all this? What do you see in your organization, in your work? Let us know in the comments. And if you want to learn more about how to use effectively AI in your software development process, we have a great learning program called AI-Powered Software Engineering, which is receiving a lot of praise from our participants. Usually after the first day, people start applying in production. It's over 4 afternoons, but after the first day, they start applying things in production, and then they already see benefits. So join us. Thank you kindly for the view, and until next time, remember to think, design, and work smart. See you next Saturday.